Dear student, in this video we studied there is a electronic effects. In generally this electronic effects topic, all kind of organic topic is covered. Okay, because this is a most basic fundamental of the all kind of organic chemical reactions. So it's a very important subtopic in the GOC. Okay, so what are that kind of electronic effect is there means that is first case there is a inductive effect. Okay, there is a inductive effect. This inductive effect is classified in plus I effect, and another one is a minus I effect, like that. Okay, then second category there is for the resonance effect. Resonance effect here this representing again two types. One is a plus R effect, another one is a minus R effect. And the third one that is for mesomeric effect. Okay, so this mesomeric effect also is classified in two types. One is a plus M effect and another one is a minus M effect. Okay, so the next there is a fourth category that is for hyperconjugation. Hyperconjugative effect. This hyperconjugative effect also called there is a Baker-Northern effect. This Baker-Northern they have proposed in this effect. That's why there is a hyperconjugation effect. Also there is a Baker-Northern effect. And last one is for there is a electromeric effect. Okay, the last one as a electromeric effect. So that's all. These five kind of the effects is there. Okay. Now see that inductive effect. This inductive effect is classified in two types. One is the plus I effect, another one is the minus I effect. Actually, this inductive effect only for electron transfer through the sigma bond. Okay, it's a sigma bond. The electron transferred only through the sigma bond. So that is a classified in two types. One is a plus I effect, another is a minus I effect. The next, this inductive effect also there is a representing in the case of electron withdrawing group and electron donating group. This category is generally all electronic effect is covered. Okay, the plus I effect that is called electron donating group and minus I effect is called electron withdrawing effects. Okay, so now the sigma bonded way the electrons are transferred. Okay, so this is a permanent effect. This is called a permanent effect because we cannot nullify any reagent added into that reactant. If the added of reagent also the effect is behaving or it occurred. Okay, the next category there is a at least minimum 4 carbon or 3 carbon. Okay, there is a occurred minimum 3 or there is a 4 carbon. It's a occurred. So more than 4 carbon. Okay, more than 4 carbon. More than 4 carbon, that effect is a failure. That effect is cannot occur. Okay, this effect is failure. So that's a very weak effect, especially in the case of the electron transferred only through the sigma bond. See the plus I effect group. In generally the plus I effect there is another category of electron donating group. Okay, so in generally the all alkyl groups are the plus I group. That's such as electron donating group. Methyl, ethyl, propyl, this isopropyl is a tertiary butyl group. If like that, the number of alkyl group increases, the plus I effect also increases. Okay. Next, the application of the plus I effect. It's an application of the I effect. Okay, there is a I effect. In generally, the application means there is a stability of carbocation, stability of carbanion, free radical, like that we can explain here. For example, the stability of carbocation application, the stability of electron deficient species. Electron deficient species as directly proportional of electron donating group. Okay, and the inverse of electron withdrawing group. And also there is a electron rich species. There is a inverse of electron donating group and directly proportional of electron withdrawing group. Here the carbocation and free radical they have electron deficient species. Okay, and also there is a carboanion or electron rich species. Okay, for that reason there is a carbocation and free radical they have if substituted more number of alkyl group. Because of alkyl group has a electron donating group, especially plus I effect. For that reason, there is a carbocation and free radical that have more number of substitution. Its stability also increases. Okay, so there is a stability order. The stability order. See, first case there is a very most stable. The CH3 carbon plus CH3. Here this CH3. Okay, so this each methyl group they have behaving as plus I effect. So plus I means there is an electron donating group. For that reason, this electron deficient carbon they have fulfilled from the electron gain in the 3 methyl group through the plus I effect. So that's why there is a tertiary carbocation as more stable compared to there is a secondary. For example, CH3, CH plus here as a CH3. Here there is a only there is for 2 methyl group behaves as a 2 electron donating group, especially substituting this carbon. Okay, so then the primary, for example, the ethyl carbocation here is a only one methyl group are substituted. Very lesser stable there is for there is a a methyl carbocation. Because this methyl carbocation, the 3 hydrogen can be substituted in the carbon of a plus charge containing species. So here this hydrogen they cannot donating electron or withdrawing electron. It is just substituting this carbocation of that carbon. Okay, so the stability order of carbocation: tertiary most stable, secondary, primary very lesser for that methyl carbocation. Okay, so there is a most very important in the case of free radical, see this free radical also electron deficient species. The carbon is substituting this 3 methyl group, and second category CH3, CH3. This also is a secondary free radical, and the primary free radical CH3, CH2 dot and methyl free radical. Okay, so there is a tertiary, secondary, primary very lesser for methyl free radical. The free radical also they have containing in the tertiary in the 3 plus I effect, and that secondary they have 2 plus I effect. Primary it has 1 plus I effect group can be substituted. Okay, so there is a the plus I effect group they have electron donating group. For that reason there is a the electron deficient species of free radical. Actual the tertiary is the most stable, secondary, primary very lesser for that methyl free radical. Next we move to the carbanion. See this carbanion, there is a CH3 CH3 minus is for that tertiary. In the case of here, there is a 3 plus I effect can be substituted in this carbanion, and there is a secondary CH3, CH minus, and CH3. These can be substituting for plus I effect, and CH3, CH minus, CH2 minus. There is also plus I group 1 can be substituted. Actually, there is a stability is a inverse of stability of carbocation like that. There is CH3 minus is the most stable, because see in the case of methyl anion CH and here H. This anion actually there is a electron rich species. The electron rich species already it has high electron density. If the hydrogen replaced by this methyl group or the tertiary butyl anion, considering here methyl group has a plus I effect, this carbon already possessing the electron rich, so this also electron donating group, actually its stability is decreases. So that's why the carbo anion stability order for methyl anion is more stable, then primary, then secondary, tertiary is a very less stable. Okay, so these are the inductive effect electron very important area. And also another one application, the see the dipole moment. The dipole moment mu is directly proportional of electron withdrawing group. Electron withdrawing group is directly proportional, or mu is directly proportional to minus I effect, inversely proportional to plus I effect. So in the case of minus I effect, the high electronegative or high electronegative, they have that higher dipole moment or higher minus I effect. The minus I effect order there is here all halogens. Actually this minus effect order is given in that textbook. I will show later. All halogens. If you assume that among the halogens there is a fluorine is greater, chlorine, the next there is a bromine very lesser for that iodine. So in the case of top to bottom, its electronegativity decreases. For that reason minus effect also decreases. Next we go to that application of acidity and basicity. Acidity and there is a basicity. In the case of acid base depends on that arginous acid and Lowry Bronsted Lewis acid that will be studied in the equilibrium unit, especially ionic equilibrium. First case there is a electron donating group and electron withdrawing group. There is a electron donating group, they have directly proportional of basicity, and inversely proportional of there is a electron withdrawing group, inversely proportional of basicity. Electron donating group directly proportional of basicity and inversely proportional of that is for acidity. Okay, so this is a very important. The electron donating means for there is a plus I effect. Electron donating group for plus I effect, electron withdrawing group as a minus I effect groups. Okay, so this is very important. For example that in the case of two phenomena is there, especially the distance rule or distance effect first case. Another one second case actually there is for power rule. Okay, there is a power rule or power effect. So these two rule or two effect are very important in the case of arginous acid. For example, see that is acetic acid. First case there is a distance effect. First case there is a distance effect. See there is a acetic acid or chloroacetic acid CH2Cl COOH, and there is a alpha chloropropanoic acid CH3CHCl COOH, and there is a beta chlorobutanoic acid, there is CH3CH or there is a beta chloro the propanoic acid CH3Cl, here CH2COOH. Okay, so in the case of this COOH group as a acid functional group, here the proton can be replaced from here only. So these two is here is a more acidic. Suppose we see here these two is the same molecular formula. Here this chlorine is substituted as a second carbon of the first this second carbon, or there is an adjacent of the COOH group. But in the case of here the chlorine can be substituted as the 1 to apart from that COOH group 1 to second carbon here. Okay, or 1 to third carbon. So this chlorine is a more close to substituted in this molecule. So there is a more electron cloud pulled from the oxygen hydrogen bond. That's why there is a acidic character for this compound is greater compared to this. So this like that the distance increases, actual acidity decreases. So the distance increases, the acidity decreases. For that reason there is a distance rule, acidity or inverse of the distance. And there is a power rule, there is a power is directly proportional to of acidity. Okay, so this is very important. For example, in the case of fluoroacetic acid, and there is a chloroacetic acid, and there is a bromoacetic acid. Okay, so here there is a plus minus I effect order. For the fluorine is greater than chlorine, then bromine. So the minus I effect increases, actual acidity increases. So there is a power, actually there is a fluorine is the highest compared to bromine and chlorine. Okay, so it's like that. Also the number of the fluorine also is greater. Like whatever that, the simple concept, the more electron withdrawing group, especially minus I effect group, is substituting at the more rear of the COH group, that can be more acidic. Okay, so and also it's a vice versa the basicity. So simply I'm saying that this is a very important in that acidity and basicity concept. Okay, thank you to all. We will see that later for the remaining electronic effect of mesomeric and resonance effect, electromeric effect, hyperconjugation. Okay, thank you. If you like in this video, you can subscribe and share your friends. Okay, thank you to everyone.